Right. So we need to understand the concept of a limit. So limits are written like this. Limit of a function. Our function are using here is x squared. As x approaches some value. So if I ask for the notation for limit, it looks like this. The limit of f of x as x approaches e. What does that mean? Right? One simple way to look at that limit is like this. Let's pretend we have a tree. There's a ground there. There's a tree, and let us say there are fruit here. Let me say the fruit is liquor stick, right? And this is about 6 centimeters, right? So as we approach this fruit here, right? What height are we approaching? 6. And that's the contour or limit. So as we approach the fruit, the height we are approaching is 6 centimeters. Are you okay with that? So that's the concept of a limit. As you approach some value, you want to know what that function approaches. Are you okay with that? So a limit is the value a function approaches, right? As x approaches some particular value. So for example here, a nice simple example here. Limit as x approaches 2 of a function of this function here of x squared. Right? So let's approach 2. If we approach 2, if we approach this point here, if we approach this way, the y value is how much? 4. If we approach 2 from this way, y value is also 4. So what that means is as we approach 2, regardless of the side, we get in a function, we get in a value of 4. All right? So if I ask you, what is the limit of x squared as x approaches 2? The answer is 4. But you'll recognize the only way I could validate this is if as the approach from the left and the right is the same thing. You recognize that? So the only way this limit here will exist is if as you approach 2 from the right and you approach 2 from the left, both of them giving you the same answer, which is 4. That's the only way a limit will exist, right? If you approach from the right and you approach from the left and you get the same value, limit exists, right? So Shivish, what about if I approach 4? I want to approach x is 4. Look at the graph. What will be the limit? It'll be 16. If I approach 4 from the right, I get in 16. If I approach 4 from the left, I am also getting 16. Same answer, limit exists. Huh? Right. And remember, when you're approaching, don't approach here. Approach on the function. So approach on the function until you reach 4. And you get in 16. Approach on the function. When you reach 4, check your value. Okay with that? So this is very important, right? This symbol here means to the right. This symbol means from the left. That's okay? So if you approach from the right, you use a plus sign. If you approach from the left, it's a minus sign. Suppose I gave you a function like this. I want to specify something here, right? I want to make sure you see it. This is a hollow circle, right? That's a solid circle. What does hollow mean again? Right. So if I say x is more than or equal to 1, I would do a solid circle. Means 1 included, right? If I were to say x is more than 1, I'll use a hollow circle, which means that the 1 is not included. Okay? So let's take a look at this function here. This is 0, right? This function f of x. Let's see what's the limit as x approaches 0 of f of x. Right? To officially have a limit, we have to check it from the right, Sarah. and we have to check it from the left. That's the only way a limit could truly exist. That's okay? So Sarah, if you approach 0 from the right, means you're starting on the right and you're going towards 0. If you do that, what's the value? What do you think? You're approaching from the right and you reach it close to 0. This is x is 0 here. You're approaching what? 2. You're approaching y is 2. Correct? Azaria, if you approach from the left, and again, you should 1. You're approaching 1. It doesn't, this 1 doesn't have to exist. You are approaching 1. Okay? So the answer here is 1. Okay? Hollow or solid, it don't matter. When you approach from the left, you are approaching the y value of 1. So what you will say, Eden, what you would say, since these two values are not the same, what you would say about the limit? It doesn't exist. It doesn't exist. Very good. One more thing I have to show you. I have to show you if a point, or at a point, if it's continuous or not. So you want to know if something continuous or discontinuous. So watch this here. This is continuous. Correct? This is discontinuous. That's okay? Sometimes they will ask you, is the function continuous at a point? Or is a function discontinuous at a point? We have to be able to prove that. So how do we show something continuous? Right? We have 3 rules to follow. Here's the first rule. Rule number 1, limit must exist. So for example, suppose I wanted to use this one down here, and I want to know if it continuous at 0. Is it continuous at 0? No, because the limit doesn't exist. So because this first statement doesn't hold, ignore that one time. Discontinuous. So if this good, then move on to step number 2. F of A must exist. So the point must exist. So F of A must exist. So for example, if you go using 2, then F of 2 must equal to some value key. Must. Right, so the first thing, the limit must exist. Second thing, F of A must exist as well. And third thing, so the limit as x approaches, A must be equal to F of A. Both of them must be equal. Okay, so let's check out right here. Right? Let's check out right here, Shivish. Let's check out this here. Let's check out at x equal to 2. Is this function continuous? Right? So let's start with number 1. Does the limit exist at x equal to 2? Yes. When x approaches 2, the limit is 4. So part 1, the answer is 4. Okay with that? Right. What is, so the limit as x approaches 2 of x squared. Shivish, what is f of 2? Huh? F of 2 is what? When I plug 2 in here, is what? It's 4. Is it solid or hollow? I was just pointing out something. So it's solid, right? Yeah? So f of 2 is 4. Are they equal? The limit as x approaches 2 of x squared is equal to f of 2. Therefore, continuous. What about here? Let's check out at x equal to, well, 0. Is it continuous? Is it continuous? Doesn't even make sense continuing, right? It's not continuous. Why, Adrian? Why is it discontinuous? The limit doesn't exist, right? First rule, limit must exist. Does the limit exist when x is 0? No, doesn't exist. Okay, so therefore discontinuous. All right, so watch here, right? So this here is the function f of x. We need to understand this first part here. For a function y is equal to f of x, as x approaches some number a, the function f of x approaches some limit f. For example, in the graph above, as x approaches 2, f of x is 4. Right? I showed you that already, right? It's the same function we'll do now again. Next, if you approach 2 from the left, you'll also get plus 4. Notice I use the right symbol, negative sign above the 2 represents from the left. Right? If you approach from the right, notice should be a plus, right? Right? So that plus sign means from the right. And since they are the same, the limit exists. Add that rule there, right? For a limit to exist, as the approach on the left and the right, it must be equal. Right. So there is a function there that I really need to draw. I'm not sure if I ever showed you how to do this, but it's called a piecewise function, right? The function is split up into 3 parts. All of this here belongs to the same function. When the function is less than 0, the answer is 0. When the function is equal to 0, the answer is 1. When the function is more than 0, it's x squared. So we have to draw something called a piecewise function, right? So at the top, here is x is 0, right? That's the most important part, right? When it's less than 0, function is 0. When it's equal to 0, function is 1. And when it's more than 0, it's x squared. I'm drawing it hollow here, and then all the way up here. Why did I put hollow there? Because 0 not included when it's x squared, right? So what you have in front of you there is a piecewise function. Just follow what I did. When it's less than 0, it's always 0. So I draw a line on the on the x-axis. When it's equal to 0, it's a singular point. So I drew a solid circle at the point 1. And then when it's more than 0, I drew the x squared function. But notice there's no x squared on this side, only on the right side. And one thing I made sure and highlighted was that x is not 0 is not included there. So tell me what you all think. For this function, does the limit exist at x equals to 0? Try that first. Right, as you approach from the right, you are approaching 0. As you approach from the left, you're also approaching 0. Therefore, the limit exists. So the answer is yes. Right, here's the hard part now. Is it continuous? Right, so the first rule in continuous is, does the limit exist? The limit exists. So the first rule, okay, right? When x approaches 0, the answer is 0. Second rule is what? F of 0. Look at your graph. When x is 0, should be. When x is 0, the function is 1, right? Right? They are not equal. They are not equal, therefore, discontinuous. All right, let's do one more like this. Oh, those are the rules of continuity. Write it down. Let's try a hard one. I know it's a little challenging, but we should remember how to sketch graphs. right? We are only interested between minus 1 and 2. Let's see if we can catch this graph. Actually, before this here, I'm not helping you. I'm doing the first part for you. When x is less than minus 1, the answer is 0. Follow on the end here. Right. What does x squared look like? Let's remind you. X squared looks like this. X squared minus 1, it will drop to 1. Correct? Remember that? Minus 1 means up, means it's going down 1, right? Good. How are we drawing this now? If you look at the graph, we don't want some parts of it, right? The graph has to go from minus 1 to 2. So we know its general shape, right? So let's just plug in minus 1 in there. But what you will get? Minus 1 squared is 1, 1 minus 1 is 0. So your graph going like this. When x is 1, comes back up again, that's 0. When x is 2, 2 squared minus 1 is 4 minus 1 is 3. So we're coming up here to 3. Notice I have a hollow circle again. You okay with that? Kill it? No? So what you say? Kill it. This is x squared. So x squared minus 1 is down there. Okay? But do you want the whole function? No. You want how it behaves between minus 1 and 2. So you have to plug in the boundaries. Plug in minus 1 and you will get here. Plug in 2 and you will get here. Right? And leave out this and leave out that. Right? And the last one is a what? 5 minus x is a what? A curve, a straight line. A straight line. Right? With a negative gradient. Right? So which way will it go? Down or up? It will go down. Right? Have a little question. Look. It's defined here when x is 2. Right? So when x is 2, plug in 2 here. 5 minus 2 is 3. So therefore, what do I do with this hollow circle here? I'll have to pull it up. And then go down. So that there is your piecewise function for this f of x. And yes, you have to learn to draw. Now, check and see, please. Is it continuous at minus 1? Is it continuous at 2? Hurry up. Do that fast. Right. Let's check out the first one. So when x is minus 1, first thing first. Step 1, let's see the limit x is. So the limit as x approaches minus 1 from the left. When you approach minus 1 from the left, right, you still get 0. When you approach minus 1 from the right, you also get 0. The limit as x approaches minus 1 of f of x is 0. Right? So that's step 1. Step 2 now. Step 2, f of minus 1. Does f of minus 1 exist? Look at minus 1. Hollow circle, solid circle, hollow, right? So f of minus 1 doesn't exist. You okay with that? It doesn't exist. So therefore, we conclude discontinuous. Without the graph, can you identify that it doesn't exist at minus 1? Without the graph. You're seeing that? Minus 1 is not defined there. So we don't need the graph all the time. Some methods you have to have the graph, some you don't. Right. What is f? What is the limit of f of x if x approaches 2? Yeah? But as they approach from the right and as they approach from the left with the same y value. Right? So yes, it's 3. What about f of 2? What is f of 2, Adrian? 3. Is it solid? Is it solid? Yes. So it's 3. Very good. Continuous or not? Continuous. Very good. Because the limit as x approaches 2 is equal to f of 2, therefore continuous. Nice job. Let's go again. What's this one here? This one we had to work in reverse. Question said it is continuous. So therefore, this is what we know. So we know that the limit exists. So as you approach from the right and you approach from the left, they equal. Correct? So notice there's no graph here. See, it's two functions, one here and one here. How do you know which one will be used when you're approaching from the left? And how do you know which one to use when you're approaching from the right? That's not true. Very good. Right? When you approach from the left, use less than function. When you approach from the left, use the less than function, right? When you approach from the right, use the more than part, right? You can answer that, please. As you approach from the right, we're using this function, so that'll be a. Don't write x squared, just write 3. That's okay? And if you're approaching from the left, use this function. That'll be a by 3 plus 2. All right, so all you have to do to get it is just plug in this value for x. Plug in this value for x. Those are the endpoints. So you'll get 9a is equal to 3a plus 2. Carry across 3a, and you'll get 9a minus 3a is 2. So you'll get 6a is 2, a is 1, 2. Let's try this one here now. Find the value of b if it's continuous. So as you approach 2 from the right, which function are you using again? One on top or below? On top. Nice. So that'll be 2 squared plus 1 is equal to b by minus 1. Nice. 4 and 1 is 5. 5 minus 1 is 6. B is 3. You all could use that, or you could also use the limit as x approaches 2 of f of x is equal to f of 2. You could have also done that. F of 2, plug in 2 in here. So that'll be 2 squared plus 1. And the limit, all you have to do for the limit is just plug in 2 in the next one. All right? So you could have also used that and you would have gotten b by 2 minus 1 on the same principle. All right. What you say earlier? So just like how you have theorems for logs and theorems for summation and deviation, you have limit theorems, deviation. Right? So here we have some rules that we can use for a limit. Right? So for example, if you have the limit of x approaches, let's say 2 of 5 f of x, you don't have to multiply the 5 by f of x. You can take the 5 and bring it in front. So you will get 5 by the limit of x approaches to f of x. So you'll end up with 5 of whatever this is. That's okay? If you have a product on the other hand, right, what you could do is you could write them separately. So the product could be written like this. Limit as x approaches a of f of x multiplied by the limit as x approaches a of g of x. So you can split it up, right? If you have a plus sign in the middle, same thing, you can split it up. If you have a division sign, same thing, limit on top, limit underneath, right? And this one is very important because in one of the past papers, they gave you something like this, the square root of 2x, and people started to panic. How to do that? But it's quite simple. You could take this square root and put it outside. Right? So this rule is important. That's okay? If the power is a half, just work out this like normal and put it to the power of a half. That's okay? So how do we apply this now? Well, In order for us to apply it, we have two rules that we can use, and the third is to check. Right? You have two rules to use. You can factorize, you can divide by the highest power, or you can check it with L'Hopital. You cannot use L'Hopital for your solution. Just to check your answer. All right? So let's start here. We have a nice example here. How do we work out the limit of this? Well, the first thing you would normally do, Shivish, is plug in 2 here, plug in 2 here, plug in 2 here. You'll end up with 4 minus 4 over minus 2 plus 2, which is 0 over 0, which is undefined. That's okay? If it's undefined, we have a problem. We need a value. So when it's undefined, we have to come back here and use technique 1 or technique 2. Right. Here's what we're going to do now. We are going to try to simplify this. Right? One of the rules that is said that we could use is something called factorization. So let's factorize here. You'll end up with x by x plus 2 on this here x plus 2. What will happen? Cancel off. So you'll end up with x alone. So you'll end up with the limit as x approaches minus 2 of x. All you have to do now is plug in your minus 2. So if factorization does not work, you divide by the highest power. So what is one here? So you want to solve something like this. If you plug in infinity here and here, you'll get infinity over infinity undefined. But we need an answer. Right? Right? We need an answer. So therefore, we have to try different techniques. So let's see if we can factorize. X squared minus 4 looking factorizable. And they'll cancel off. No help. Right? So factorization didn't work. So now let's try something else. Let's try to divide by the highest power of x. The highest power of x is 2. So I'm going to divide everything by x squared. I'm going to divide all these terms by x squared. The objective is to simplify to get an answer. All right? What would happen here? This will cancel. So you'll get 3 over x. X squared on x squared as 1. 4 on x squared will be, well, 4 on x squared. That's okay? Next step, let's substitute x is infinity. So I'm going to put 3 over infinity, 1 minus 4 over infinity. Anything divided by infinity is what? Anything divided by infinity is 0. So you get 0 over 1, which is 0. So the limit of this is 0. All right? So basically, right, we have two options when we simplify this. Well, what are the two options, Shivish? So you factorize, right? So you factorize or you divide by the highest power. You okay with that? Try factorization first. If it doesn't work, then try division by the highest power. All right? So the objective is to move from undefined to some value, right? So once again, undefined, you have to use method 1, factorization, or method 2, divided by the highest power.